Hello class, this is a video tutorial on quadratic functions. These are also known as parabolas. If the largest power in an equation is 2, it is a quadratic function. So for example, ax to the power of 2, notice how this 2 is the largest one. This entire thing will be considered a quadratic function. So here are 3 examples of what it might look like. X squared plus 3, still a quadratic function. Notice how it has this component and this component. Y equals half x squared minus 4. This one has this component and this component. And this last one has negative 3x squared minus 12x. So it has both of these components. It's still a quadratic function. The general shape of a quadratic function looks as follows. And here are the key features that we'll go through each one. If a parabola is either concave up or concave down, if the value of a, so this one here, is positive, it is concave up. So for example, if it's positive 2x squared, 5x squared, or in this case it's just positive x squared, it is concave up. And it's concave down if it's negative, so half x squared, negative 7x squared, or in this case it's just negative x. So concave up, concave down. The steepness, or how close the parabola is affected by the value of a. So for example, if you have a quarter x squared, it's very open. Half x squared, it's getting closer. Positive x squared, so this is a 1x squared, this is the normal one. If it's 3x squared, it gets closer. And if it's 4x squared, it gets even closer like this. So the larger the value of a in front of x squared, the more close or more spread apart the parabola is. The turning point of a parabola is called a vertex. Notice how there's a point here where the parabola turns along. It's turning along that point there. That point there is called a vertex. It is called the maximum if it's concave down, and it's called the minimum if it's concave up. And I'll demonstrate to you why this is. So this point here is called the maximum because when it's concave down, that is the highest point that this entire graph can reach. So this is concave down. It has the highest point. Whereas this one, it's concave up. Therefore, this point is the lowest point it can reach. Therefore, it's called a minimum. And lastly, the vertex is always halfway between the y-intercepts. So for example, since we can see that it starts on 0 and hits the x-axis again at 20, this is a distance of 20. Halfway would be 10. So the vertex here, even though it's drawn improperly, that would be 10. In this case here, this is a distance of 30. So halfway between this is 15. So 10 plus 15 more is 25. So at x equals 25, that is the point where the vertex will be found. So let's get to some graphing of these. Let's graph the following using a table of values from x equals negative 3 to x equals positive 3 and state whether the parabola is concave up or down and the coordinates of the vertex and x-intercept. I've actually already drawn the 4 of them, like so. You can go ahead, pause the video and try and graph these yourselves. But I'm going to demonstrate to you when it comes to typing these in that you should really use brackets. And I'll demonstrate to you why that is. If you were to put -3 squared, you get -9. But this should definitely be +9. And the reason for that is you should be placing it in a bracket like so. +9. So if when you place that, oops, sorry, that's 2 brackets -3 squared. So that's me substituting 3 into x on that point there. That gives me 18. Substituting -2, get 8. Substituting -1, 1, we get 2. Graphing these points, 3, 18 is off the chart. Let's just graph what we have. So 2, 8, -1, 2, 0, 0, 1, 2, 2, 8. And there is all that we can graph. Trying to draw these as smoothly as we can into a curve, like so. And there we have it. Oop, that should go all the way up to 18. And there we have it. And from this, we can now write down whether it's concave up or concave down. This is nice and simple. This is concave up. It has one x-intercept. So at this point, it touches the x-axis. So x-intercept at 0, 0. And the vertex, v, so happens to be the same point. So the vertex is also at 0, 0. Repeating the same process for this. Let's try graph these out. Be very mindful with the values that you are substituting in. So here we go. -half bracket -3 squared. -4.5. Since we have this, we can just erase the 3, putting 2 in, get -2, substituting -1, -0.5. You'll know that you've done it correctly if in your table of values it's matching on the opposite sides, as you can see here. Graphing these out, we will get 3, -4.5, 3 looks approximately here. That's 5, 4.5 would be here. In actual fact, we can do 2 at a time, going on either side like so. There's both like this. -2. That's at 2. So like so. -1/2. 1 is here. Half would be here. And 0, 0. Graphing these out. My graph has been thrown off from the looks of it. Interesting. That doesn't look correct, does it? And in any case, I hope you get the idea of what we're aiming for. So it should look somewhat like so. And for this one, it's concave down. Its x-intercept is again where it touches the x-axis at 0, 0. And its vertex v is also at 0, 0. Notice how it's at the highest point at that point there. Here we go. It's graphing these. Going a little bit faster now, so substituting -3 squared, take away 4 is 5, -2 squared, again making sure you see that it's got that bracket outside the -2. And notice again that it's matching on either side. 5, 5, 0, 0, -3, -3. Plotting out these points, -3, 5, 2, 0, 1, -3, 0, -4, and mirroring it on the other end like so. And there we have it. So this would be concave up, concave up. Its x-intercept, here's where it gets different now. It goes through the x-axis at this point here. That's -2, 0, and 2, 0. So it's going through at those 2 points. And its vertex, v, its lowest point, or its turning point, is at that point there. The coordinates of this point are 0, 4. Sorry, 0, -4. One last one here. This time, let's substitute all these values in. Go ahead, pause the video and try yourselves, but I'm going to go rather quickly now. So -0 squared plus 6, 0. Notice how we substituted 0 for where x is on those points there. So this is at 0. Substituting 1, 5, substituting 2, we get again, 2 squared plus 6 times 2, 8, substituting 3, 9, substituting 4, we get 8 again. And I think we're going to start coming back down on the other end and mirroring what we see here. And I'm presuming that this value here is going to be 0. So substituting 6, we also get 0. And there we have it. Let's graph these points here. 0, 0, 1, 5, 2, 8, 3, 9, and as you've seen in the table of values, it mirrors along the vertex. And there we have it. This here is concave down. Its x-intercepts, if we were to continue this graph like so, will intercept at those 2 points. So its x-intercept is at 0, 0, there's 1 here, and at 6, 0, this point here. And its vertex, see, is the highest point here. Its x value here is 3, and its y value is 9. And that there is graphing quadratic functions and identifying all their key features using a table of values and a graph. Hope to see you in the next video. Best of luck.